हेलो दोस्तों, बिगनर्स पॉइंट में आपका स्वागत है। और अभी हम कर रहे हैं इकोनॉमिक्स। ठीक है, इससे पहले का चैप्टर कर लिया प्रेजेंटेशन ऑफ डाटा। अब करेंगे चैप्टर नंबर 4, इंट्रोडक्शन। यू हैव ऑलरेडी लर्न इट इन प्रीवियस चैप्टर्स हाउ डाटा आर कलेक्टेड एंड organized. As data are generally voluminous, they need to be put in a compact and presentable form. This chapter deals with presentation of data precisely so that the voluminous data collected could be made usable readily and are easily comprehended. There are generally three forms of presentation of data: textual or descriptive presentation, tabular presentation, diagrammatic presentation. Textual presentation of data. In textual presentation, data are described within the text. When the quantity of data is not too large, this form of presentation is more suitable. Look at the following cases. Case 1 Following cases. Case 1: in a Bandh call given on 08 September 2005 protesting the hike in prices of petrol and diesel, 5 petrol pumps were found open and 17 were closed, whereas 2 schools were closed and remaining 9 schools were found open in a town of Bihar. Case 2: Census of India 2001 reported that Indian population had risen to 102 crore, of which only 49 crore were females against 53 crore males. 74 crore people resided in rural India and only 28 crore lived in towns or cities, while there were 62 crore non-worker population against 40 crore workers in the entire country. Urban population had an even higher share of non-workers, 19 crore against workers 9 crore, as compared to the rural population where there were 31 crore workers out of a 74 crore population. In both the cases, data have been presented only in text. A serious drawback of this method of presentation is that one has to go through the complete text of presentation for comprehension, but it is also true that this matter often enables one to emphasize certain points of the presentation. Tabular presentation of data. In a tabular presentation, data are presented in rows, read horizontally, and columns, read vertically. For example, see table 4.1, tabulating information about literacy rates. It has 3 rows for male, female, and total, and 3 columns for urban, rural, and total. It is called a 3 into 3 table, giving 9 items of information in 9 boxes called the cells of the table. Each cell gives information that relates an attribute of gender, male, female, or total, with a number, literacy percentage of rural people, urban people, and total. The most important advantage of tabulation is that it organizes data for further statistical treatment and decision making. Classification used in tabulation is of 4 kinds: qualitative, quantitative, temporal, spatial. Qualitative classification. Well, classification is done according to attributes such as social status, physical status, nationality, etc. It is called qualitative classification. For example, in 4.1, the attributes for classification are sex and location, which are qualitative in nature. Literacy in India by sex and location percent. Sex: male, female, rural, urban, total 79, 90, 82, 59, 80, 65, total 68, urban में 84 और total 74. Quantitative classification. In quantitative classification, the data are classified on the basis of characteristics which are quantitative in nature. In other words, these characteristics can be measured quantitatively. For example, age, height, production, income, etc. are quantitative characteristics. Classes are formed by assigning limits called class limits for the values of the characteristic under consideration. An example of quantitative classification is given 4.2. Calculate the missing figures in the table. Distribution of 542 respondents by their age in an election study in Bihar. Age group 20 to 30, respondent 3%, 0.55. 30 to 40, 61, 11.25, 40 to 50, 132, 24.35, 50 to 60, 153, 28.24. Here classifying characteristic is age in years and is quantifiable. Heights in centimeter, weights in kilogram of students of your class. Temporal classification. In this classification, time becomes the classifying variable and data are characterized according to time. Time may be in hours, days, weeks, months, year, etc. For example, see 4.3. Yearly sales of a tea shop from 95 to 2000. 95 79.2, 96 81.3, 7 97 82.4, 98 80.5, 99 100.2, 2000 91.2. In this table, the classifying characteristic is sales in a year and takes value in the scale of time. Spatial classification. When classification is done on the basis of place, it is called spatial classification. The place may be a village, town, block, district, state, country, etc. Table 4.4 is an example of spatial classification. Table 4.4 Export from India to rest of the world in 2013-14 has share of total export percent. USA 12.5, Germany 2.4, other EU 10.9, UK 3.1, Japan 2.2, Russia 0.7, China 4.7, other Asia 29.4 or 18.8. Tabulation of data and parts of table. To construct a table, it is important to learn first what are the parts of a good statistical table. When put together systematically, these parts from a table, the most simple way of conceptualizing a table is to present the data in rows and columns along with some explanatory notes. Tabulation can be done using one-way, two-way, or three-way classification depending upon the number of characteristics involved. A good table should essentially have the following. Table number. First, table number is assigned to a table for identification purpose. If more than one table is presented, it is the table number that distinguishes one table from another. It is given at the top or at beginning of the title of the table. Generally, table numbers are whole numbers is in ascending order if there are many tables in a book. Subscripted numbers like 1.2, 3.1, etc. are also used for identifying the table according to its location. For example, table 4.5 should be read as the fifth table of the fourth chapter, and so on. See table 4.5. Title. The title of a table narrates about the contents of the table. It has to be clear, brief, and carefully worded so that the interruptions made from the table are clear and free from ambiguity. It finds place at the head of the table, succeeding the table number of or just below it. See 4.5. Captions or column heading. At the top of each column in a table, a column designation is given to explain figures of the column. This is called caption or column heading. See 4.5. Stubs or row headings. Like a caption or column heading, each row of the table has to be given a heading. The designation of the rows are also called stubs or stub items, and the complete left column is known as stub column. A brief description of the row headings may also be given at the left-hand top in table. See 4.5. Body of the table. Body of a table is the main part and it contains the actual data. Location of any one figure data is the table is fixed and determined by the row and column of the table. For example, data in the second row and fourth column indicate that 25 crore females in rural India where non-workers 2001 C4.5 Unit of measurement. The unit of measurement of the figures in the table actual data should always be stated along with the title. If different units are there for rows or columns of the table, these units must be stated along with stubs or captions. If figures are large, they should be rounded up and the methods of rounding should be indicated. See table 4.5. ये है टेबल 4.5, टेबल नंबर ये हो गया, टाइटल पॉपुलेशन ऑफ ये हो गया, कॉलम हेडिंग इधर, यूनिट्स कौन कौन सी हैं करोड़ में है, रॉ हेडिंग ये हो गई, बॉडी ऑफ द टेबल, सोर्स कहाँ से लिया है, नोट क्या है, ये सब हो गया। इसके बाद सोर्स जो भी देखा था, इट इज़ ब्रीफ स्टेटमेंट ऑफ फ्रेज indicating the source of data presented in the table. If more than one source is there, all the sources are to be written in the source. Source is generally written at the bottom of the table. Note is the last part of the table. It explains the specific feature of the data content of the table, which is not self-explanatory and has been explained earlier. Diagrammatic presentation of data. This is the third method of presenting data. This method provides the quickest understanding of the actual situation to be explained by data in comparison to tabular or textual presentation. Diagrammatic presentation of data translates quite effectively the highly abstract ideas contained in numbers into more concrete and easily comprehensible form. Diagrams may be less accurate but are much more effective than tables in presenting the data. There are various kinds of diagrams in common use. Amongst them, the important ones are the following: geometric diagram, frequency diagram, arithmetic line graph. Geometric diagram, bar diagram, and pie diagram come in the category of geometric diagram. The bar diagrams are three types: simple, multiple, and component bar diagrams. Now, bar diagrams, simple bar diagram. Bar diagram comprises a group of equispaced and equivalent rectangular bars for each class or category of data. Height or length of the bar reads the magnitude of data. The lower end of the bar touches the baseline such that the height of a bar starts from the 0 unit. Bars of bar. A diagram can be visualized compared by their relative height, and accordingly data are comprehended quickly. Data for this can be frequency or non-frequency type. In non-frequency type data are particular characteristics, say production, yield, population, etc. at various points of time of different states are noted, and corresponding bars are made of the respective heights according to the values of the characteristic to construct the diagram. The values of the characteristics measured or counted. Retain the identifier of each value. Figure 4.1 is an example of a bar diagram. Different types of data may require different modes of diagrammatical representation. Bar diagrams are suitable both for frequency type and non-frequency type variables and attributes. Discrete variables like family size, spot on a dice, grades in an examination, etc., and attributes such as gender, religion, caste, country, etc., can be represented by bar diagrams. Bar diagrams are more convenient for non-frequency data such as income, expenditure profile, export imports over the years, etc. A category that has a longer bar, literacy of Kerala, than another category, literacy of West Bengal, has more of the measured or enumerated characteristics than the other. Bars, also called columns, are usually used in time series data. Food grains produced between 1980 to 2000. Decadal, decadal variation in work participation. Literacy rates of major states of India 2001-2011. Male female. आंध्र प्रदेश 70.1, 50.4, मेल में 75 और 59, ये पूरा डाटा है। टोटल अगर इंडिया में देखें 75.3 है और 53.7 2001 में था, तो 2011 में 82.1 और 65.5। ये क्या हो जाता है, बार डायग्राम। ठीक है, बार डायग्राम में ऐसा होगा। रेट रजिस्टर्ड अनएम्प्लॉयड ओवर द ईयर्स, लिटरेसी रेट्स एक्सेट्रा, ये सब फिगर हो गए। ये जो अभी दिया था 8.2, 82.7, बस इसको इस तरीके से लिख दिया है। Bar diagrams can have different forms, such as multiple bar diagrams and component bar diagram. Multiple bar diagram, figure 4.2, are used for comparing two or more sets of data, for example, income and expenditure or import and export for different years, marks obtained in different subjects in different classes, etc. Component bar diagrams or charts, also called subdiagrams, are very useful in comparing the sizes of different component parts, the elements or parts which a thing is made up of, and also for throwing light on the relationship among these integral parts. For example, sales proceeds from different products, expenditure pattern in a typical Indian family, components being food, rent, medicine, education, power, etc. Budget outlay for receipts and expenditure, components of labor forces, population, etc. Component bar diagrams are usually shaded or colored suitably. Interpretation: it can be very easily derived from figure 4.2 that female literacy rate over the years was on increase throughout the country. Similar other interpretations can be made from the figure. For example, the figure shows that the states of Bihar, Jharkhand, Uttar Pradesh experienced the sharpest rise in female literacy rate. Table 4.7: Enrollment by gender at schools. Percent of children aged 6 to 14 years in a district of Bihar. Boy 91.5, out of school percent 8.5, girl 58.6, 41.4, all 78.0, 22.0. A component bar diagram shows the bar and its subdivisions into two or more components. For example, the bar might show the total population of children in the age group of 16 to 14 years. The components shows the proportion of those who are enrolled and those who are not. A component bar diagram might also contain different component bars for boys, girls, and the total of children in the given age group range, as shown in figure 4.3. To construct a component bar diagram, first of all, a bar is constructed on the x-axis with its height equivalent to the total value of the bar. For percent data, the bar height is of 100 units, figure 4.3. Otherwise, the heights is equated to total value of the bar and proportional heights of the components are worked out using unitary method. Smaller components are given priority in parting the bar. इसके बाद आ जाते हैं पाई डायग्राम. A pie diagram is also component diagram, but unlike a bar diagram, here it is a circle whose area is proportionally divided among the components. 4.4 its represent. ऐसा होता है पाई डायग्राम. It is also called a pie chart. The circle is divided into as many parts as there are components by drawing straight lines from the center to the circumference. Pie charts usually are not drawn with absolute values of a category. The values of each category are first expressed as percentage of the total value of all the categories. A circle in a pie chart, irrespective of its value of radius, is throughout of having 100 equal parts of 3.6 degree 360 degree upon 100 each. To find out of the angle, the component shall subtend at the center of the circle. Each percentage figure of every component is multiplied by 3.6 degree. An example of this conversion of percentages of components into angular components of the circle is shown as 4.8. It may be interesting to note that data represented by an by a component bar diagram can also be represented equally well by a pie chart, the only requirement being that absolute values of the components have to be converted into percentages before they can be used for a pie diagram. Distribution of Indian population 2011 by their working status means crore. Marginal worker population 12% 9.9 angular 36 degree. Main worker 36 2.9 107. Non worker 73 60.3 20217। पाई चार्ट ये हो गया। फ्रीक्वेंसी डायग्राम अब ये करेंगे कल।